Hello, this is my demo lesson for Revolution Prep. My name is Andre Law, and I'm very excited for the opportunity to be selected to advance to the next step of the uh, process in terms of hiring for your tutors. It is quite an honor. And so my lesson today is going to be on how to add integers using counters, what we call colored counters. And this is a picture of what colored counters look like. And if this were in a virtual classroom or in a traditional classroom setting, I would actually hand students the manipulatives, or in the virtual classroom, we would actually do some virtual chips. So these are what they are. So today we're going to talk about how to add integers using colored counters. Now, key thing is, very quickly, if you recall from previous lesson, what we talk about as integers. Integers are what we call our negative and positive numbers. Negative and positive whole numbers, right? So for example, negative 50 would be an integer. Negative 275 would be an integer, and so on. But when we think about the key thing when we talk about integers is how do we recognize these crazy fancy numbers in real life? And so temperature is a great example that we could use to illustrate integers, temperature, because once we get below zero, the numbers become negative. So when we say 20 degrees below zero, we're referring to a negative whole number, which makes that an integer. And of course, if we say 10 degrees above zero, we're referring to a positive integer. So we're going to get started today with our color counters. So hopefully you're able to see the PowerPoint that's been generated. I'm doing a screen share simultaneously while I am going through this lesson. So typically a yellow counter would represent a positive 1, while a red counter would represent a negative 1. So red is negative 1, a yellow counter represents a positive 1. What happens when you put a negative 1 and a positive 1 together? We get what is called a zero pair. And we're going to talk about that in a minute a little bit more. So the following collections of counters have a value of positive 5. Let's see why. Here, in the first example, we have a zero pair. A zero pair means that a positive 1 and a negative 1 cancels out. So this is gone. And so what we have left here is 1, 2, 3, 4, 5. And there are 5 yellow ones, so that makes it positive, right? Over here, we have 1, 2, 3, 4, 5 red, which means that they are negative, right? And so we're going to make zero pairs. 1 negative cancels with 1 positive. So we have a total of 5 zero pairs. They sum to 0, right? A negative 1 and a positive 1 cancels each other out. And so we have 1, 2, 3, 4, 5 positives left over here. Similarly here, we have 1, 2, 3, 4 reds. So that's 4 negatives. We're going to make 4 zero pairs if we can. So 1, 2, 3, 4. And so what's left is 1, 2, 3, 4, 5. Positive 5. 5 yellow ones means that they're positive. So we have a positive 5. And for the last example of value of positive 5, here we have three red counters. So we're going to try to make three zero pairs if we can. That's 1, 2, 3. This one does not have a value of positive 5. We could see the 3 zero pairs are gone. So this one actually has a value of positive 3. So this is the one that's up, right? So what is the small? Let's erase this. What is the smallest collection of counters with a value of positive 5? So as you build collections of 2 colored counters, use the smallest collection, but remember that there are other ways that we can make positive 5 using the red and yellow counters, okay? So if you want to do the smallest collection of positive 5, it would just be 5 yellow counters, right? That's the smallest collection. But there are many other combinations that you could use. So if you wanted to use a combination of red and yellow, you could do, let's say 7 yellow counters and 2 red counters, or we could do 6 yellow counters and 1 red counter. Those are all combinations that would give us positive 5. Now, let's look at this next one. The collections shown here are 0 pairs. So remember earlier I talked about this idea of 0 pairs, right? A positive and a negative sums to 0. And so here, if you have 2 yellows and 2 reds, they're going to cancel each other out. So they're summing to 0. Here we have 3 yellows and 3 reds. They sum to 0. 4 yellows and 4 reds also sum to 0. So you can see the pattern now, right? Whenever we have the same or equal numbers of yellow and red counters, we get a sum of 0. All of them cancel out. 0 pairs are formed. Nothing's left over. So how would you describe a 0 pair based on what we just talked about? So a 0 pair, hopefully this glare is not, is a equal number of yellow and red counters, or a positive and negative number that sums to 0. So by definition, a 0 pair is either an equal number of yellow and red counters or a positive and negative number that sums to 0. Positive 5 plus negative 5 sums to 0. Positive 100 plus negative 100 sums to 0. Positive 1 million, negative 1 million sums to 0. So now we're going to look at models for operations with integers when we're adding, right? So you know your basic addition is combining one or more addends, right? So we're going to talk about a collection of counters. So let's look at this example. We have a numeric sentence there, positive 5. We don't need to say positive 5 because we know the sign's not in front. It's going to be positive, right? So 5 plus negative 3. How can we represent this visually using our counters? So we know already that the positive counter is represented by yellow. So if we have a positive 5, we're going to have 5 yellow counters. And then we have negative 3. We're going to represent that with negative 3 would be 3 red counters. And then we try to get our 0 pairs up. So if we cancel out our 0 pairs, 1 yellow with 1 red, we have 3 0 pairs gone because they sum to 0. And then what's left is 2 yellow, which would be positive 2. Let's look at one more example. here. We have a 8 plus negative 3. We're going to represent this first with our negative 3 would be 3 red counters, right? And then our yellow counters are going to be 1, 2, 3, 4, 5, 6, 7, 8. Let me just redraw the red ones again. 3. And now we're going to have our 0 pairs. They cancel out, right? 1 negative with 1 positive sums to 0. And what we have left is 1, 2, 3, 4, 5, positive 5. Super. So hopefully you enjoyed this demo lesson, and certainly, again, very humbled by the opportunity to advance to this next screening level of the interview process with Revolution Prep. And hopefully you have seen a little bit of my energy and enthusiasm and my passion for teaching. Have a great